All right, so we are going to do trapezoids, and actually the title of section 6.5 is trapezoids and kites. Okay, we're going to save kites for tomorrow. Today we're just going to talk about trapezoids. You already know what a trapezoid is, Silas? Okay, it'll be on YouTube, so make sure you look there. All right, so let's draw a trapezoid. Do you remember what a trapezoid is? What it looks like? Yeah, it's weird, but what do we know about it? Now that you're looking at it, it may come to your memory. How many parallel sides does it have? Well, how many pairs? I should say that. How many pairs? One pair. One pair. There's two sides, that's true, but one pair. And it only has one pair. All right? One and only. Okay, can only have one pair of parallel sides. So we already knew that. We already knew that a trapezoid has that. We also know something else about a trapezoid already before I even teach you what we're going to learn today. What do I know about a trapezoid already? It's what? Is it? It's not a parallelogram. Okay, it's not a parallelogram. Why? Because a parallelogram doesn't have one set of parallel sides. It's got two sets of parallel sides, two pairs of parallel sides. Trapezoid is different. Okay, trapezoid is not a parallelogram. Let's list some parallelograms real quick. What are some of the parallelograms? Square, rectangle, rhombus. Okay, those are my parallelograms. Everybody got that? This is not a parallelogram. But we do know something. We know something about this angle, and we know something about this angle right here. What's true about those two angles? They add up to 180. So give me the good geometry word. They're supplementary. Okay, good. Yeah, you're getting that quick. I'm liking that. All right, so these two are supplementary. All right. Now, did you say the opposite sides are equal? Look at it though. What kind of angle do we have here? It's obtuse. This is acute. Do you think the opposite angles are equal? No. It is true about a what though? The opposite angles are equal when it's we just talked about parallelogram. Okay, it is true on a rectangle, but generally about a parallelogram. It's not true about a trapezoid. The opposite angles are not equal to each other on a trapezoid. Everybody got that? Okay, but what do we call these, the ones that are next to each other? We had a good geometry word. It starts with a C. Consecutive, right. The consecutive angles are supplementary, all right? But that's old. We already knew that, okay? What we're going to do is talk about a specific type of trapezoid, okay? Not just any old trapezoid, okay? A specific type. And I tried to draw it so it was specific. So I tried to draw it so that this side equals this side. What kind of trapezoid is it if two of the sides, the legs, we call these the legs. What do we call the parallel sides? The what? The base, that's right, okay? So this is a base and this is a base. This is a leg and this is a leg, all right? When the two legs are equal to each other, we give it a name. And we gave the same name to some other triangle. When two sides are equal on a triangle, what do we call it? What is it? Isosceles. Very good. Okay, isosceles. All right. So this is not a triangle; it's a trapezoid. And if the two legs are equal to each other, what do you think we call it? An isosceles what? Trapezoid. Exactly. Not hard. All right, so this is an isosceles trapezoid. How do I know that? Because the two legs are equal. That's the first part that you need to understand. Okay, that's just the definition of an isosceles trapezoid. It's not a theorem. Really haven't learned anything new. We learned some time ago about an isosceles trapezoid. So far, we haven't learned anything new. It's all been review. But here's the first theorem. The first theorem says that the base angles, which ones, I'll tell you what, let's do this. A, B, C, D. Which ones are the base angles? Give me one pair of base angles. Silas? D and C, right. So D and C are base angles. There's another set of base angles. What would they be? A and B, correct. The theorem says this. Everybody ready? And what do you think might be true? I always like to do that because you could probably look at it and kind of guess. AB are what? Equal to each other, exactly. So A and B, I shouldn't say AB, but angle A and angle B are equal to each other. What else do you think is equal to each other here? Angle D and what? angle C. Does that mean that angle A and angle D are equal to each other? No, they're not. Okay? And they won't be. They never will be. All right? So, but that's what you have. That's our first theorem. Okay? Our first theorem says it only is about an isosceles trapezoid. That's not true about every other trapezoid. So let me just draw another trapezoid for you just to show you. Let's do it like this, okay? I'll make it really extreme. That's still a trapezoid, but is that an isosceles trapezoid? No, there's no way that this side and this side are equal to each other. Would you agree? All right, so that's not isosceles. So so that means that on this, if I could talk, on this trapezoid, are the base angles equal to each other? No, they're not. They're only equal to each other when it's what? An isosceles trapezoid. Very good. Everybody good with that theorem? Yeah, super easy. No big deal. These two angles are equal. These two angles are equal if these two legs are equal to each other. Everybody good? Let's see another one. All right, what if I had this? What if I did not tell you that that side and this side were equal to each other? What if I did not tell you the legs are equal, but what if I told you that angle A equals angle B? So if I have a trapezoid, I did tell you this is a trapezoid, okay? These two sides are parallel. It is a trapezoid, and what if I told you that this angle and this angle are equal to each other? What do you think then I could say about the two legs? It's kind of going backwards of what we just did, okay? It's going the other way. The first thing that we said is that the two legs are equal. What does that mean about the base angles? The base angles must be what? Equal. So if the two legs are equal, then the base angles are equal. What this one is saying is kind of the opposite. If the two base angles are equal to each other, what do you think must be true about the two legs? They're going to be equal to each other as well. That's right. Okay, it's like the converse. You just flip the if and the then, right? If the legs are equal, then the base angles are equal. Flip it. If the base angles are equal, then the legs are equal. Everybody see that? That's called the converse of the statement. Everybody good with that? All right. So if that's all I knew, is that it was a trapezoid, and I didn't know that it was isosceles, but I do know that these two base angles are equal, that means that these two legs are equal, and that means it is a what? An isosceles trapezoid. Okay? And if it's isosceles trapezoid, what's true about these two angles right here? Then they got to be equal. Everybody see that? All right. So that's not too hard, is it? Really simple. We got one more thing. They're going to throw some diagonals in there. Okay, they always do, don't they? So that's what we're going to do right now. So let's change colors. Let's make it yellow. All right, let's throw some diagonals in here. Now again, I just want you to look at it. We're not really going to prove it. I'm just going to tell you what's true about it. Just looking at those two yellow lines right there, what do you think is possibly true about those two yellow lines? What does it look like? Does it look like one's shorter than the other? Does it look like they're equal to each other? What do you think? Saz, what do you think? You're nodding your head. The sides? The lengths of them, right. The lengths of the diagonals. It absolutely looks like they're equal, doesn't it? Right? If I go from one corner to the other, then this one to this one, if it's an isosceles trapezoid, okay, it has to be an isosceles trapezoid. If it is an isosceles trapezoid, then the diagonals are going to be equal to each other. Then we can flip it around. Let's do the converse of that. Remember we just talked about converse? So what would the converse be? What if I did not know it was isosceles trapezoid, but I knew that AC was equal to BD? What if I knew that those diagonals were equal to each other? Then what could I say about this trapezoid? Then I could say it's a what? It's an isosceles trapezoid. Clea's playing along. Thank you. All right. Everybody with me on that? So if I know it's isosceles, then the diagonals are equal. What if I don't know it's isosceles, but I know the diagonals are equal? Then I could say it's what? Isosceles just because of that fact. Everybody good? All right, I guess. We'll see. We got 5 minutes. Let's do an example. We'll just use this same picture, so I don't have to redraw it because it'd be basically the same thing. We just get rid of some of these words. We don't need those anymore. All right, so we do know that it's an isosceles trapezoid. They tell us it's isosceles. So let me put some measurements in here, and we're going to find some measurements, right? That's what we've been doing all year long. Let's see. They tell you that angle ABC is 125 degrees. ABC, that's this big angle right here. This is 125. It's hard to read a little bit, isn't it? But write it in there. That whole angle right there is 125. And they also tell you, now this is weird, they tell you that AC, let's write it down, AC is 7x. And then they also tell you that BD is 4x plus 12. I think you see where they're going with this, don't you? Here's a couple questions that they ask. Let's do this one in white. So part A, they ask you a bunch of them. They ask you 6 questions. And I don't think we're going to, I don't know, we'll try to finish as many of these as we can. So they want you to find angle BAD. They want you to find angle ADC. They want you to find angle ABD, ABD. And they also want you to find angle ACD. Man, there's a lot of angles. Then E, I want to find AED, angle AED, and then F, AC. All right, here we go. Everybody ready? This shouldn't be too hard. BAD. So BA, let's do this in a different color. BAD, that's this whole big one right here. That's super easy. What's that angle right there? Without any math at all. What's this pink angle right here at angle A? Abby, tell me. 125. Very good, because the base angles are equal, right? It's an isosceles trapezoid, which they told us the base angles are equal, so that's 125. Very good. All right, let's find ADC. Where's that? ADC is this one right here. How do I find that one? If I know this is 125, how do I find this? That's it. Take it away from 180. So 180 minus 125, it's what, 55? Yep. So this angle right here is 55. What's ABD? ABD. That's this little guy right here. Let's do a different color. This one right there. I think I missed something. Yep, I was going to say, you can't figure that out with this information. They tell you something else. I forgot what they tell you. They tell you that this is 30 degrees. All right, now you can find it. I knew I was missing something. So watch, if that's 30 degrees, what's this angle right here, this orange one? 30, because they're alternate interior angles, right? We've done that before. I got to go quick because time's running out. All right, ACD, ACD, that's this one right here. So if that's 30, and this is, I'm sorry, if this one's 30, what do you think this one's going to be? 30, all right? I could go through and show you why, but AED, oh, have a seat. We're not done. Belt and ring. I know, but I want you to sit. AED, I want to find this one right here. Okay, that angle right there. What could you do? Well, this is 30. That's 30. What's this big angle right there? 30 and 30 is 60. This has got to be 60. And this has to be what? I'm sorry. Hold on. AED. AED. This is 30 and 30. That's 60. 180. That's not 60. 180 minus 60 is what? 120. Right. So that big angle is 120. What's this one right here? That's 60. So that's 60 degrees. All right. One more thing. AC. How do we do that? Look at this thing right here. They tell you AC and they tell you BD. What are you going to do with both of those things? They're both diagonals, right? So what are you going to do to find x? Set them equal to each other. So 7x equals 4x plus 12. Hang on, the bell's going to ring pretty soon. So let me finish this first before you leave. Subtract 4x from both sides. That gives us 3x equals 12. What's x? Divide by 3. X is 4. Now, I got to find AC. So I put 7 times 4 is what? 7 times 4 is 28, and that's that. All right, I know I rushed through that, but you can always go back and look at the video, slow it down, pause it, try it yourself, all right, and figure out what I was saying there. All right, so you have an assignment. You got the lesson plan, and it is 1 through 12. So it should all just be trapezoids. So you're doing 1 through 12 on section, what is it, 6-5? Yep. So we'll call it 6-5A. That's your homework, 1 through 12. This is your next to last homework. So let's get it done. Let's turn it in on time. Let's do your best on it, okay? You only got one more homework after this, all right? Everybody got that? Good, look at that timing. So make sure you get it done. Turn it in tomorrow. We want to get as many points on your grades as you possibly can.